Dear students, welcome. This is our class number 16 on statics. Let us start. First, let us try to solve these two problems. Question number 11. Today's question number 1. PQR are three like parallel forces acting at A, B, C respectively of the triangle ABC. Let me draw the triangle ABC. ABC. Like parallel forces. PQR are like parallel forces. PQR are like parallel forces acting at A, B, C of the triangle ABC. If their resultant passes through the centroid C, suppose this is a point. Suppose the resultant of PQ and R passes through the centroid of the triangle. Suppose G is the centroid of the triangle. Triangle ABC. Let me write first. Let the three like parallel forces. PQ and R are acting at the vertices, acting at ABC of the triangle. ABC respectively of the triangle. You may write respectively of the triangle. Respectively of the triangle ABC. Now, the resultant of Q and R acting at B and C is Q plus R. Suppose it acts at the point D of BC. Let the resultant Q plus R of the forces Q and R Q and R acting at B and C respectively acts at D, acts at the point D of BC, acts at the point D of BC. Therefore, we get Q into BD equal to R into DC or CD, R into CD. Suppose this is number 1. QBD equal to R into CD. The resultant of the like parallel forces Q and R acting at B and C respectively will be Q plus R, and it acts at the point D. And D is a point on BC. Therefore, we get Q into BD equal to R into CD. Now, the resultant of P and Q plus R. Now the resultant of P and Q plus R acting at A and B, respectively the resultant will act at some points of AD, respectively will act some point on AD will some point on ABC. Suppose this point is G. Yeah. Suppose this point is G. Suppose this point is G. G is a point on AD. G is a point on AD. Therefore, P into AG equal to Q plus R into GD. Q plus R into GD. Now, this means Q plus R divided by P equal to AG by GD. AG by GD. Suppose this is number AG by GD. This is number 2. Suppose this is number 2. According to the question, the resultant, according to the question, the resultant passes through the centroid of the triangle ABC. The resultant of P, Q, and R passes through the centroid Z, passes through the centroid of the triangle ABC. But the resultant of P, Q, and R acting at A, B, C respectively is the same as the resultant of P and Q plus R acting at A and D. Now, the resultant of P, Q, and R acting at A, B, and C respectively should be equal to the resultant of P and Q plus R acting at A and B respectively. But the resultant, I am not removing this one, but the resultant of P, Q, R acting at A, B, C, A, B, and C should be equal to the resultant of P and Q plus R. Resultant of P and Q plus R acting at A and D respectively. This means that Z is the centroid of the triangle and D must be the midpoint of it. This means that Z is the centroid of the triangle. Is the centroid of the triangle ABC. Triangle ABC, and we must get AG by, we must get, after this you may write here, AG by GD equal to 2 by 1. AG by GD equal to 2 by 1. We must get this, and D must be the midpoint of BC. And after this, you write, and D must be the midpoint of, be the middle point of, D must be the middle point of BC. Right? Now, from 2 we get, suppose this is number 3. From 2 and 3 we get D must be the middle point of BC, and therefore D is the middle point of BD equal to DC. DC or CD. BD equal to CD. And therefore B is equal to C. Now, from 2 and 3 we get. Let me remove this one. From 2 and 3 we get. From 2 and 3 we get. From 2 and 3 we get Q plus R by P equal to AZ by ZD means 2 by 1. This means twice P equal to Q plus R, 5. Equal to Q plus R, 5. This is number 5. Also, 1 and 4 we get. From 1 and 4. 1 and 4 we get. From 1 and 4 we get Q equal to R. Q is equal to R. This is number 6. From 5 and 6 you will get. From 5 and 6 we will get. From 5 and 6 we get twice P equal to Q plus Q. This means twice P equal to twice Q. This means P equal to Q. 5 P equal to Q. This is 7. 6 and 7 implies P equal to Q equal to R. The magnitudes of the three forces, like P, Q and R are like parallel forces, and their magnitude should be same. If their resultant passes through the centroid, then their magnitude should be same, should be equal. Very interesting problem. Perhaps you have understood this one. Now let us come to solve the question number 12. Let us come to solve the question number 12. What is it? First, let me make this one. What is it? If the resultant of 3 like parallel forces PQ are acting at the vertices passes through the incenter of the triangle ABC. Passes through the incenter of the triangle ABC. Then we have to prove that P divided by A, small a. What is small a? Let me remove this one. Passes through the incenter. BCA, like parallel forces. Suppose these 3 forces P, Q and R, like parallel forces. Suppose this is the let the 3 like parallel forces PQR. Let the 3 like parallel forces PQR are acting at A, B and C respectively of the triangle ABC. C respectively of the triangle ABC. Of the triangle ABC. Let the resultant Q plus R. Let the resultant Q plus R of the like parallel forces Q and R acting at B and C respectively. Acting at B and C respectively. Act at D. At D of BC. D is a point of BC. Of BC means D is a point of BC. BC such that we must have Q into BD equal to R into CD or DC. You may write CD or DC. There will be no problem. You will get this one. Now, the resultant, given that the resultant of PQR of the three like parallel forces, PQR passes through the incenter of the triangle ABC. Passes through the incenter of the triangle ABC. The resultant of the like parallel forces PQR passes through the incenter of the triangle ABC. But the resultant of P and Q plus R, resultant of P and Q plus R, these are like parallel forces of like parallel forces. You may write like parallel forces, which is equal to P plus Q plus R. Resultant will be P plus Q plus R, and the resultant of the original forces P, Q and R acting at A, B and C is also P plus Q plus R. But the resultant of P and Q plus R, resultant of like parallel forces P and Q plus R acting at A and B, acting at A and B, must pass through some point on AD, but this point, by question, this point is the incenter, but by question, this point is the incenter of the triangle ABC. But by question, this point is the incenter of the triangle ABC. This point is the incenter of the triangle ABC. What does it mean? This means that AB bisects the angle A. This means that AB bisects the angle A, means BAC. That is BAC. AB bisects the angle BAC, right? Bisects the angle BAC. Therefore, we must have. since it bisects the angle BAC, therefore we must have BD by BC equal to AB by AC, BD by BC, AB by AC. For that, this by this, this by this. For that, these two angle will be same. These two angle will be same. But AB is denoted by small c and AC is denoted by small b. This is equal to small c by small b. Small c by small b. This means BD by BC equal to C by B. Suppose this is number 2. This is number 2. Now one implies BD by BC equal to R by Q. This is number 3. 2 and 3 implies. From 2 and 3 implies means from 2 and 3 we get R by Q equal to C by B. R by Q, this is equal to C by B. This means Q by B equal to R by C. R by C. Suppose this is number 2. Similarly, we can prove that P by A equal to Q by B. P by A equal to Q by B. AB is a line on BC. Similarly, if you take a line, suppose CF, which passes through the point I, means in center, then you will get P by A equal to Q by B. From 4 and 5 we get. From 4 and 5 we get. From 4 and 5 we get P by A equal to Q by B equal to R by C. Proved. We have proved that question number 2 also. What is small a? Small a is the side BC of the triangle ABC. Small b, AC of the triangle ABC. In the class 11 level, you have already learned. You have already got this. Therefore, we have proved these 2 problems. Let us take some more problems. First, let me remove this. Let us try to solve these 2 problems. Question number 13 and 14. Today's question number 3 and 4. Number 13. 3 like parallel forces PQ are act at the vertices of the triangle if their resultant passes through the circumcenter. In the today's first question, resultant passed through the centroid of the triangle. In the second question, if the resultant passes through the centroid of the triangle, P is equal to Q is equal to R. Resultant passes through the incenter of the triangle, then P by A equal to Q by small b equal to R by small c. And if the resultant passes through the circumcenter of the triangle, then P by sin twice A equal to Q by sin twice B equal to R by sin twice C. It's very interesting, and let us try to solve this problem. Suppose O is the incenter of the triangle. O is the incenter of the triangle. ABC is the triangle O. Suppose O is, I am writing here. Let me write O in center of the triangle. Suppose this is B, D. We draw perpendicular. this and this. We draw these two perpendiculars. Suppose the length of the perpendicular is h and it is suppose h dash. Like parallel forces. P, Q, R are like parallel forces. P, Q, R are like parallel forces acting at A, B, C respectively. Their resultant passes through the circumcenter of the triangle. Their resultant passes through the circumcenter of the triangle. Now, let me write. The three like parallel forces. P, Q, R are acting at A, B and C respectively of the triangle ABC. Let the resultant Q and R, let the resultant Q plus R of the forces Q and R acting at B and C respectively acts at the point D, at D of BC. D is a point of BC. At the point D, the resultant of Q and R acts at the point D. Therefore, Q into BD equal to R into DC. Q into BD equal to R into CD or R into B. Since the resultant, this is the resultant Q plus R are acting at this. Q plus R of resultant of Q and R are acting at Q and R is acting at the point D. This is again a like parallel process. This means that BD by DC equal to R by Q. Suppose this is number 1. BD by DC equal to R by Q. This is number 1. Now, resultant passes through the circumcenter of the triangle. Let O be the circumcenter. The resultant of PQ and R. Resultant of PQ and R passes acting at A, B and C, A, B, C passes through the circumcenter of the triangle. Center O of the triangle ABC passes through the circumcenter O of the triangle ABC. Now, resultant passes through this. Let H and H dash be the H and H dash be the perpendicular polar distances from O and A on BC respectively. H and H dash are perpendicular distances. from OMA on BC. This is H dash. Thus, this is H dash. BD. Now, you may write. Let us join. First, we join OB and OC. We join OB and OC. OB and OC. Join OB and OC. OB and OC. Now, 1 in place. Now, from 1 we get. From 1 in place. R by Q, this is equal to BD by DC. This is equal to, what is BD? You may write half of H. Half of H into BD. Half of H into DC. Half of H into BD, what does it mean? Half of H into BD, it is nothing but the area of the triangle OBD. It is nothing but the area of the triangle OBD. Half base into altitude, half into BD into OH, or into H. This is equal to the area of the triangle OBD. And BC, area of the triangle ODC. ODC. Area of the triangle ODC. ODC. This stands for the area of the triangle OBD. OBD. This is equal to area of the triangle OBD. Now, R by Q equal to this. This is number 2. Again, R by Q equal to BD by DC. Similarly, DC, ODC means area of the triangle ODC. This is equal to half of H dash BD, half of H dash, multiply numerator and denominator by H dash. Now, half of H dash into BD, what does it mean? It means that the numerator denotes the area of the triangle ABD. This is equal to area of the triangle ABD, half of DC into DC, H dash into DC, area of the triangle ADC. Suppose this is number 3. It means that the area of the triangle ABD and ADC, half base into altitude, half into base DC, altitude is H dash, half base into altitude, the area of the triangle. From 2 and 3, from 2 and 3, R by Q equals to area of the triangle ABD, area of the triangle ADC equal to area of the triangle OBD, area of the triangle ODC should be equal to ABD minus OBD, ADC minus ODC, right? This minus this, this minus this. This means that, R by Q equal to ABD minus OBD, ABD minus OBD, ABD minus OBD equal to AOB. AOB divided by ADC minus ODC. ADC minus ODC will be equal to AOC, area of the triangle AOC. Now, the area of a triangle ABC equal to half into product of any two sides into sine of the included angle. This is equal to half into product of any two sides. Half into product of any two sides. AOB, consider the triangle AOB. AO into BO into sine of the included angle AOB. Here AO, CO, sine of the included angle AOC, sine of the included angle AOC. Included angle AOC. Now, this is where you know the area of the triangle ABC equal to half of AB sine C, half of BC sine A equal to half of CA sine B. You have already got this. Half into product of any two sides into sine of the included angle. Here, half of this formula has been applied here. Now, AO is equal to BO equal to CO equal to circumradius. Suppose this is equal to half. Circumradius R. Sine AOB R. Sine AOC equal to this angle is B. Why is B? Why is B? Where I am writing here, where AO equal to BO equal to CO equal to R equal to circumradius of the triangle ABC. Circumradius means the radius of the circle is called the circumradius of the triangle ABC equal to R. Also in any triangle ABC, suppose this is a circle. This is a chord, AB is a chord. It makes an angle at the center will be equal to 2 times of this angle. This angle will be equal to 2 times of this angle. Another you may write here also. This angle equal to 2 times of this angle. This theorem has been applied here. You have already got this in class 9 or 10 like that. The chord made by the chord at the center will be equal to 2 times the center here, 2 times of the angle here. Therefore, angle AOB will be equal to 2 times of angle this, 2 times of angle this. What is this? This is equal to C. This is equal to C. Also, AOC, this angle will be equal to 2 times of angle this. This is nothing but B. Now, perhaps you have understood this. This means that R by Q equal to sine twice C by sine twice B, or Q by sine twice B equal to R by sine twice C. Similarly, we can prove that. Similarly, we can prove that. Similarly, we can prove that. P by sine twice A equal to q by sine twice b. Therefore, finally we will get p by sine twice a, q by sine twice b equal to r by sine twice c. If the resultant passes through the circumcenter of the triangle, then p by sine twice a equal to q by sine twice b equal to r by sine twice c. Some simple application of geometry which you have already got in high school level. That is, p is to q is to r equal to sine twice a is to sine twice b is to sine twice c. Sine twice c. It is very easy. Now p by sine twice a equal to q by sine twice b equal to r by sine twice c. This means p by twice sine a into cos a equal to q by twice sine b into cos b equal to r by twice sine c into cos c. Sine c into cos c. This means that 2 will be cancelled. Now a by sine a equal to b by sine b equal to c by sine c. Therefore, p by sine a will be equal to a by twice r. Cos a means b square plus c square minus a square divided by twice bc. You will get this one. This is equal to q divided by b by twice r. Cos b means c square plus a square minus b square divided by twice ca. You will get this one. This is equal to r divided by c by twice r. A square plus b square minus c square divided by twice ab divided by twice ab. This means since a by sine a equal to b by sine b equal to c by sine c equal to twice r. Sine a equal to a by twice r, therefore twice r will be cancelled. This means that you may write ABC 2 and r. 4r will be cancelled. 4r. ABC p divided by a square b square plus c square minus a square equal to ABC q divided by b square c square plus a square minus b square equal to ABC r c square a square plus b square minus c square a square plus b square minus c square. This ABC will be cancelled. This means p by a square into b square plus c square minus a square equal to q by b square into c square plus a square minus b square equal to r divided by c square into a square plus b square minus c square. A square plus b square minus c square. This we have solved the question number 30 fully. Perhaps you have understood this one. It is very easy. This ABC will be cancelled from all sides. Then you will get this one. 3 problems have been solved here. Now, if the resultant passes through the orthocenter, then what will happen? Passes through the orthocenter. Just let me read. The resultant passes through the orthocenter. Resultant passes through the orthocenter. Then we will get this result. Passes through the orthocenter. If the resultant passes through the orthocenter, then we will get this one. Now, Suppose this ABC. Same thing. The resultant passes through the ortho center. Suppose O is the ortho center. It will be like this. The forces PQR are acting. The forces PQR are acting at ABC of the triangle ABC. The forces PQR are acting at ABC of the triangle ABC of the triangle ABC. These are like parallel forces. Let the resultant Q plus R, magnitude is Q plus R, if you Q plus R of the like parallel forces Q and R acting at B and C respectively. B and C respectively, X and D of BC, X and D of BC, D of BC. Therefore, we must have Q into BD equal to R into BC, R into BC. This is number one. Q into BD, and you may write this is number one. No problem. This is number one. Now, the resultant of PQR acting at ABC respectively is the same as the resultant of P and Q plus R acting at A and D respectively, but the resultant of P and Q plus R acts at some point, but the resultant of P and Q plus R acting at A and D will act some point on A and D. Will act some point on A and D. On AD. Will act some point on AD. But by question, this point is the orthocenter. But by question, this point is the orthocenter of the triangle. This point is the orthocenter of the triangle ABC. But by question, this point is the orthocenter of the triangle ABC. What does it mean? This means that AD is perpendicular on BC. Since O is the orthocenter, the resultant passes through the orthocenter, and the resultant passes through the orthocenter. Also, the resultant of Q and R passes through the point D, and the resultant must pass through a point on AD. This means that AD must be perpendicular on BC. This means that from this it is clear that it is clear that AD must be perpendicular on BC. Therefore, it is clear that AD is perpendicular on BC. Therefore, it is clear that AD is perpendicular on BC. It is clear that AD is perpendicular on BC. AD is perpendicular on BC. It is clear. Now, BD by AD. BD by AD will be equal to cot of angle B. Will be equal to cot of angle B from triangle, of course right triangle, from right triangle ABD, from right triangle B, of course from right triangle, because AB is perpendicular on BC. Therefore, BD by AD, base by perpendicular, will be equal to cot of angle B. This means BD equal to AD cot B. AD cot B, suppose this is number 2. This is number 2. Now, this is number 2. Now, again, from right triangle, ADC we get. From right triangle ADC we get. DC by AD equal to cot C. This is angle C. DC by AD equal to cot C. This means DC equal AD cot C. Now, using 2 and 3 in 1 we get. 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 Q into, what is BD? BD is equal to AD cot B. Equal to R DC AD cot C. AD cot C. Now AD will be cancelled. AD will be cancelled. This means Q cot B equal to R cot C. This means Q by cot B, 10B, Q by 10B equal to R by 10C. R by 10C. Similarly, we can prove that. Suppose this is number 2. This is number 4. Similarly, we can prove that. Similarly, we can prove that P by 10I equal to Q by 10B. It is suppose number 5. From 4 and 5 we get. From 4 and 5 we get. 4 and 5 we get. P by 10 equal to Q by 10B equal to R by 10C. Proved. We have proved this one. P by 10 equal to Q by 10B equal to R by 10C. Perhaps you have understood this one. Now, come to the second part. It is very easy. We have put the part 1. This means P by tan A means sin A You may write P cos A by sin A equal to Q cos B by sin B equal to R cos C by sin C. This means that sin A means A by twice R. P, you may write here B square plus C square minus A square divided by twice BC. You may write like this. This is equal to Q C square plus A square minus B square divided by twice C B by twice R. This is equal to R into A square plus B square minus C square divided by twice AB. C by twice R. Since A by twice R, B by these are different. Therefore, twice R, 2 will be cancelled. Now, let me write. This means that ABC P into B square plus C square minus A square divided by ABC 2 and R will be cancelled. This is equal to Q into C square plus A square minus B square divided by ABC. This is equal to R by R into, this is equal to R into A square plus B square minus C square divided by ABC. This means P into B square plus C square minus A square equal to Q into C square plus A square minus B square equal to R into A square plus B square minus C square. A square plus B square minus C square. Therefore, we have proved this problem also. You see, if the resultant of three like parallel processes acting at the vertices ABC respectively of the triangle ABC, if the resultant passes through the centroid of the triangle, then you will get P equal to Q equal to R. If the resultant passes through the incenter of the triangle, then P by small a equal to Q by small b equal to R by small c, where small a, small b, small c denotes the sides BC, CA and AB of the triangle ABC respectively. If the resultant of three like parallel processes PQR passes through the circumcenter of the triangle, then P by sin twice A equal to Q by sin twice B equal to R by sin twice C. And if the resultant passes through the orthocenter of the triangle, then P by tan A equal to Q by tan B equal to R by tan C. We have solved all the four problems here. Let us take some more problems. First, let me remove this one. Let us try to solve these two problems also. See the question number 15. What is this? The resultant of two like parallel processes P and Q passes through the point C. Resultant of two like parallel processes P and Q. P and Q. This means that these are the magnitude of the process. The magnitude of the process, this is equal to P. It is given. You should consider it like this. The magnitude is given. P and Q passes through the point C. Resultant passes through the point C. Suppose these 2 points are acting at the point B. P plus Q. P plus Q. The magnitude of the resultant is P plus Q and R. If P is increased by R, P is increased by R and Q by S, then also the resultant passes through the point C. Not only that. If Q and R replace P and Q and R replace P and Q, then also the resultant passes through the point C. Then we have to prove this one. Let the like parallel forces. Forces P and Q, let the forces P and Q are acting. I am not giving the vector sign. It means that I am writing the magnitude of the forces are acting at the points A and C, A and B respectively. They are resulting H at C. They are resultant H at C. Therefore, P into AC equal to Q into BC. This is from the first condition. Second condition is this. R is added. So P is R is added to P means P is increased by R. Then also resultant passes through the increase. Q by S also BC. Suppose this is number. Third condition. This is second condition. Third condition. Third condition means P is replaced by Q. Q into AC equal to the resultant still passes through. And also when Q and R replace P and Q, Q is replaced by R. We have got these three conditions. From the given conditions, we have got three results: 1, 2, and 3. 1, 2, and 3. Now, dividing 1 by 2, we get 1 by 3. We get dividing 1 by 3. We get 1 divided by 3 implies. This means dividing 1 by 3. We get P by Q equal to Q by R. This means Q square equal to PR. 1 has been proved. Q square is equal to PR. Proved. Now, 2 implies from 2 we will get P into AC plus R into AC equal to Q into BC plus S into BC. S into BC. P into AC equal to Q into BC by 1. We can say R into AC equal to S into BC. S into BC. Suppose this is number 4. Using 1. We have used number 1. Using 1. P into AC equal to Q into BC. We have used number 1. Now, divide 1 by 4. AC, this time AC will be cancelled. AC will be cancelled. Dividing 1 by 4 we get. Dividing 1 by 4 we get. Dividing 1 by 4 we get. We get P divided by R equal to Q divided by S. This means PS equal to QR. PS equal to QR. The second one has also been proved. PS equal to QR. Now, in the third case, there is no P. Therefore, eliminate P from these two results. Suppose this is number 5. This is number 5 and this is number 6. Eliminate P. Eliminate P between 5 and 6. Now 5 implies P equal to Q square divided by R. P equal to Q square divided by R. 6 implies Q square by R into S equal to Q into R. This means that Q will be cancelled, QS equal to R square. R square is equal to QS. This is number 7, proved. We have proved this one. These first three results have been proved here. First three results have been proved here. Now, we have proved 1, 2, and 3. Now, from now we may remove this one also. That now we have proved. Q square equal to PR. This means that Q by R equal to P by Q. Q by R is equal to P by Q. Q by R equal to P by Q. This means that P by Q equal to Q by R equal to P minus Q divided by Q minus R. Suppose this is 567 and suppose this is number 8. This is number 8. Also, we have proved that this is R square is equal to QS. This means Q by R equal to R by S. Q by R is equal to R by S, which is equal to Q minus R by R minus S. This is suppose 9. This is suppose 9. Now, 8 and 9 in place. 8 and 9 in place. From 8 and 9 you will get Q by R equal to P minus Q divided by Q minus R equal to Q minus R divided by R minus S. R minus S. This means that P minus Q into R minus S equal to Q minus R whole square. You will get this one. Q minus R whole square. Then this means that R minus S equal to Q minus R whole square divided by P minus Q. This means that S equal to R minus Q minus R whole square divided by P minus Q. S is equal to R minus Q minus R whole square divided by P minus Q. Therefore, we have solved this totally the question number 50. We have solved totally the question number 50. Perhaps you have answered the question. You have understood this. Now, let me try to solve the question number 16. Let me try to solve the question number 16. Let me remove this. Question number 16. What is question number 16? 3 like parallel process twice P plus Q, 4P minus twice Q and 8 kilogram weight act at the vertices of a triangle. Find P and Q if the resultant of the 3 forces passes through the centroid of the triangle. ABC. Suppose like parallel process twice P plus Q, like parallel process 4P minus twice Q, and this is again 8 kilogram weight. 8 kilogram weight. B is a point, this is Z. Now, let the like parallel process, 3 like parallel process of magnitudes. These are magnitudes. Twice P plus Q, 4P minus twice Q, and 8 kilogram weight are acting at A, B, and C respectively of the triangle ABC. Of the triangle ABC respectively of the triangle ABC. Triangle ABC. Now the resultant. Now the resultant. Four Q minus twice Q plus 8 acting at B and C. Respectively, X and D. And therefore, 4P minus twice Q into BD should be equal to 8 into DC or CD. This is suppose number 1. The resultant of 3 forces passes through the centroid. Centroid G of the triangle. Therefore, G must be a point. On AD and AD such that we have already discussed like this. Discuss about this question equal to 2:1 and D must be the midpoint. Of the midpoint of BC. We have the resultant twice P plus Q into AG should be equal to 4P minus twice Q plus 8 into BG, GD. This means that twice P plus Q divided by 4P minus twice Q plus 8 equal to 8. No, GD by this divided by this. GD by DD, AG. GD by AG means 1 by 2. This should be equal to 1 by 2. GD by AG equal to 1 by 2. This means 4P plus twice Q equal to 4P minus twice Q plus 8. 4Q minus twice P plus 8. This means 4P will be cancelled. 4Q is equal to 8. This means Q equal to 2 kilogram weight. This is one answer. And from 1, this is the middle point. BD is equal to CD. BD is equal to CD. Also, BD is equal to CD. This is the middle point. Therefore, from 1 you will get 4P minus twice Q equal to 8. This means 4P minus 2 into 2 equal to 8. This is equal to 8. This means 4P equal to 12. This means P equal to 3 kilogram weight. P equal to 3 kilogram weight. Therefore, we have proved this one. Answer P equal to 3 kilogram weight and Q is equal to 2 kilogram. 2 kilogram. Dear students, perhaps you have enjoyed the class. Thanks for attending the class. Thank you very much.